Last screencast for this weekend, and it's just to help explain that octavization patch that I made in the last lecture. You probably got very confused by it, and fair enough. It was using a number of quite complex ideas and concepts. So the first thing we're going to do is just get back the octavization formula to generate the frequencies for our cycle object. So let's first of all, before we do that, we'll just create our cycle object. So let's create a new cycle 440 object. You don't have to put 440 in there because we'll be generating the frequency anyway, but let's put it in for now, and easy DAC. So this is always how we start off a lot of our audio patches. And let's be nice to our ears actually and just give that a gain. So multiply tilde of 0.2, something small, just so it's not quite so loud. It's nicer. Okay. Go away, go away. Okay. So we were going to generate the frequency of our sine wave, and it's going to jump up and down octaves. So let's choose the octave up here. So this is our octave. And this is pretty much doing exactly what I did in screencast number 3. So the octave number, the fundamental frequency over here, fundamental frequency in hertz. And then if you recall, we're going to do our POW thing here, and that was a message which was 2 to the power of the octave number, and there's the message box substitution, and that gets multiplied by that. And remember, we had to do a trigger bang I, TBI, to make sure that no matter whether this one or this one changes, we will always get a new number spit out. Okay, and that goes into there. Alright, so let's just tidy up, give you a chance to catch up. Move some of these over. Yeah. Come on. Okay, let's line those. And segmented patch chords. Right. This is looking pretty. Ish. Okay, so let's try putting in a fundamental frequency of 100 Hz and switching that on. And then we will need to set. I love those sine tones when they get high, isn't it cool? Yeah, baby. Okay. Let's turn that off. Right, okay, so this was the kind of the basic part of it, and where I got everybody super confused was by using another cycle object to basically control this. And that's one of the beautiful things about Max, actually. This is a really quite a subtle, but one of its really powerful things is you don't just have to use numbers, ints and floats to control audio. You can use audio to control audio. And the reason being that I wanted to have this number going up to, was it the 8th octave or something like that, and then back down again. And I could use, you know, something kind of y equals x, a linear ramp basically like that. But I wanted to be a little bit cooler. I mean, we could use a linear ramp. I'll show you how you might use a linear ramp. Let's use a linear ramp. Right, so counter, I think, has some options if we have a look inside it. Counter has, where is it? Hey, options. If there are, I want a direction, where is it? The first number specifies the direction of the palindrome. 1, 2, 3, 4, 3, 2, 1. Yes, that's it. So, and this is the one here. So if we want to just generate a ramp, a basic numerical ramp that goes up and down, then we can use counter 2 and then 1 to whatever number we want. So counter 2, the 2 specifies it's going to go up to the top and then back down again. Don't ask me why, that's what they decided on. And we're going to go from octave 0 up to octave 8 every time there's a bang. Okay, so let's put a button in there and try that. Oh, need to switch it on. Okay, and of course we can get a metro to run that button. Well, it's going to get the dogs screaming in your neighborhood. Let's get that going really fast. And a toggle box to start the metro. And go. It's pretty cool. So that would be a linear ramp basically going upwards and downwards. And I just wanted to be a bit funky and have a sine wave basically. So it would sweep down to, this would be, of course it's -1 to 1, a normal sine wave, but I would scale it so it would be 0 up to 8. So to scale it we would have to add 1 to move the whole thing up. And then we would multiply that by 4. So I'm using a little graphing program here just to show you what the equation would look like. I need to put all of that in brackets, don't I? There we go. Times 4. Okay. And that would go up to 8. So I'm just going to use the scale object though to avoid having to do all this crazy sort of stuff here. Let's get out of that graphing program. It's probably confusing you even more. Oh, don't save. Okay. So instead of just this linear object here, this linear ramp going up and down, I was going to use a cycle object, which generates a sine wave. And I wanted it to go up and down every second, so that is a frequency of 1. Now I can't just make that go in there. You see, it won't let me. And the reason being that is audio coming out of there, and we need to get from the audio domain back into the sort of max message domain. And that was why I used the snapshot tilde. You could have 10 or 20, or this is the reporting interval, so every 20 seconds it will spit a new number out. And this is the object that converts from the audio domain into the numerical domain. And we can see if we put a float there, and it's not doing anything at the moment. That's because cycle won't produce anything until we switch DAC on. And now you can see we're getting those numbers between -1 and +1. You notice it never quite reaches +1, which is just something we need to be a little bit aware of when it comes to scaling these numbers. It hits -1, but it never quite hits +1. So we're going to scale that sine wave from the original original minimum was -1, the original maximum was 1, and now the new minimum is going to be 0, and the new maximum is going to be 8, but we're just going to add a wee bit on, 8.1, as I say, because it never quite reached 1. I suppose I could also, the other thing I could do is to, instead of making that 1, is to make that 0.99. And that would also guarantee I would reach 8. That might be a better way to do it, thinking about it. And there we go. Let's put a key slider on here. Okay, that's getting quite a lot of fun. So really that's just explaining what I was doing in this patch. I'm using this sine wave, which is hiding behind there, this sine wave to basically control the octave number in that curvy way rather than a straight linear way. Whether or not you can hear a difference is a good question. Who knows? There are other different generators you could put in here, which we'll look at all the different generators later on in this course. But for example, I could do a phasor object. Let's see what happens now. I should say phasor object starts at 0. That's pretty cool. There's just one final little object I'll show. If you want to know what these tilde objects are actually producing, you can't sort of set a debug monitor on here, and you can't hook it up to a message box to find out either, because it's spitting out thousands of samples a second. So the most useful object is the scope tilde object. And if you hook up phasor, for example, to there and switch your ADC on, you'll see. So the basic idea is this middle line here, that's 0, and the top is 1, and the bottom is -1. So if I change that back to my cycle, I should get a nice sine wave. There we go. Whereas the phasor went from 0 to -1. There's also things like a sawtooth wave. What else? Triangular wave. Wow, scope does some pretty funky, strange things at times. I'm not entirely sure that's what a triangle wave should look like, so don't always rely on that, but in some cases it's useful. Okay, so that might give you something interesting to explore if you want to play around with that, if you want to take this octavization patch and play around with that a bit more as well. And you get some nice sine waves, and I hope that's helpful for your sine wave assignment.